This is lesson 8C3. Our learning target for today is to find the common difference when given two non-consecutive terms and their values. And then based on this common difference, we can find different values in an arithmetic sequence. And I know it's arithmetic because only arithmetic sequences have common differences. We could find the sums of sequences based on this. So let's go ahead and look at an example of a series and how we could kind of, knowing what the series is, how we could take two terms that are non-consecutive and find their common difference. So here's our series. We have 12 plus 22 plus 32 and so on. We know that our common difference is 10. Okay, and since we're starting with u sub 1, u sub 2, right? These are all of our terms. Okay. What I want to do is I want to look at two terms that are non-consecutive and figure out, let's think about how we could figure out that our common difference is 10, because if I know the series, I can kind of look at what we're doing arithmetically, mathematically, and kind of understand why the formula that we're about to learn works. So I'm going to pick u sub 2 and u sub 6. Those are going to be our two non-consecutive terms. So u sub 2 has a value of 22, and u sub 6 has a value of 62. So the question is, what relationship do these values and these term numbers play when we're trying to find the common difference? So basically what we want to do is we're going to be looking at the values together, and then we're going to be looking at the terms, the number of terms together. Alright, so what we're going to do first to find the common difference is we're going to take these values and find their difference. So we're going to take the value associated with the largest term, and we're going to deduct from that the value associated with the smallest term. So in this case, 62 is the value associated with the largest term, and 22 is the value associated with the smallest term. So we're going to find that difference. Alright, and then we're going to find another difference because I have some terms between 2 and 6, so I need to figure out, what they're growing by. So I'm going to say 6 minus 2 because I'm trying to show that, there's four terms between 2 and 6, right? And each of those terms has to grow by 10. So what we end up with is our difference of our values is 40. The difference of our term numbers is 4, which gives me a common difference of 10. Well, if I look at this, I can see that I have a common difference of 10 and 10 and 10. So the idea that we're finding the difference of the values and we're dividing that difference by the difference of the terms, the reason it works is because we're really finding how much each term grows by. Alright, and from here we could find, different values. We could find u sub 32 if we wanted. Alright, so let's do another practice one. So let's say I'm given u sub 2 equals 38 and u sub 5 equals 92. And I'm going to tell you that this is an arithmetic sequence. If you don't know what kind of sequence is, you can't really determine if there's a common difference unless they specifically ask for a common difference, because the sequence could be geometric or it could be some other random sequence. So you need to know that it's arithmetic in nature. So here we go. We're going to find the common difference. So to do that, we say our common difference equals the difference of our values. So 92, and from that I'm going to subtract 38, and then we find the difference of our terms. So how many terms from 2 to 5? So we find that difference. Alright, and we end up, when I plug this in, I get 18. So our common difference is 18. But now let's take this a step further. Now that I know my common difference, what happens if I asked you to find u sub 31? Well, the way we would proceed here is we could say, all right, I'm going to make 31 my last term. Okay, we're going to call this L because I have a formula that I can use to find the last term, and it looks like this. Okay, so if I make 31 my last term, I can go ahead and plug in different information. So at this point, I don't know A, but since I know the common difference, I can find it. So we'll talk about that in a second. I know that D, my common difference, is 18. And if I'm making 31 my last term in this sequence, that means that from 1 to 31, there's 31 terms. Okay. So let's talk about A here really quick. So A is our starting value. And basically, if our sequence is growing by 18 each time, that means that the term before term 2 has to be 18 units smaller. So I can just deduct 18 from 38, which gives me 20. So when I plug this in for A, I now have a way to find my last term. So I can just simplify this. Alright, so I end up with 20 plus 18 times 30, and I end up with a value for my last term, which is 560. Okay, since I made my last term, term 31, I can just go ahead and say u sub 31 equals 560. Alright, so moving forward, what happens if I give you, let's say u sub 21 equals negative 519, and u sub 29 equals negative 703. So we're going to start by finding the common difference, okay? Oh, and perhaps I should tell you, I want you to find the sum of 29 terms, okay? And as always, I need to state, and in any written problem I would, that this is an arithmetic sequence, because again, only 2 terms, you can't identify a pattern, so it needs to say, you know, it's arithmetic. So we know that it grows by a common difference. Okay, so our common difference, we're going to take negative 703 and subtracting from that negative 519. Okay, then I'm going to find the difference of our term numbers, so 29 minus 21. When I do this, I get negative 23. So just as a reminder, if you're putting this into your calculator, you need to put parentheses around the entire numerator and parentheses around the entire denominator. Alright, so now that we know D is negative 23, if I'm trying to find the sum, we basically are going to be using this equation, okay, that we learned in class. So I'm going to be using the one that combines, actually I'm not going to use this one, I'm going to use this one. Since I'm going to make 29 my last term, I already know what my last term is, so this is the easiest one to use. Okay, so if I'm finding the sum of 29 terms, that means I have, in fact, 29 terms, because I'm going from 1 to 29, because it's our last term. I'm going to make 29 the last term. Okay, and all I need now is my the value of my starting term. So let's go ahead and find that. So I'm going to use the equation, my last term equals my first term plus the common difference times n minus 1. Now in this case, my last term, like we did in the last example, I'm going to make u sub 29 because that's the last one we know. So I'm going to substitute 703 in for L. I don't know A, so I'm going to leave A there. I know that D is negative 23, and I know that I have 29 terms in this sequence. So I end up with 703 equals A, and then I just went ahead and did this math. I end up with negative 644. So to find A, I'm going to add 644 to both sides. And then A has a value of negative 59. Alright, so not too. I noticed I just wrote 29 for the last term here, and it's not the last term. It's negative 703. All right, so now, now that I know my value for a, I can go ahead and find the sum of this sequence. So I'm going to substitute in 29 for n, because that's how many terms I have in this sequence. I just found that my first term has a value of negative 59, and I'm going to add my last term's value to that. So, so plus negative 703 is the same thing as saying minus 703. So here's what I want you to think about. If my first term is negative and my common difference is negative, that means every subsequent term is going to be negative. So is it acceptable to have a negative sum? If you answered yes, you are correct. You can have a negative sum if some of your terms are negative, okay? As a reminder, you can never, ever have a negative number of terms, okay? A negative sum is fine because you can sum negative numbers. Number of terms, you can't have, you know, negative 10 terms. It just doesn't work. So you can have 0 terms, you can have 100 terms, but you can't have a negative number. All right, so back to this. So if I just put this into my calculator, as is, I end up getting negative 11,049. So the sum of these 29 terms is negative 11,049. So as you can see, there's a lot of power in being able to just have two terms, know the sequence is arithmetic, and be able to figure out the common difference so we can find different terms, we can find summations. Basically, this enables us to complete any of the prior tasks that we've learned. So finding the last term, finding the first term, finding, well, basic, the common difference, finding any sort of sum. So this is what we're going to be practicing in class on Thursday, or our next class meeting. So make sure that you take good notes on this because there might be a pop quiz. Have a good evening.